Welcome all to another session of problem solving. So today the problem that we have, it requires very basic knowledge in rank nullity theorem. So if you understand rank nullity theorem, then you will be able to solve this problem without uh, any without thinking about a lot of advanced stuff. So I will write down things in a perfect order so that the solution looks pretty easy even if you are actually reading rank nullity theorem for the first time. So the rank nullity theorem is something like this, that if you have a linear transformation, so where W are finite dimensional, so then rank of T plus nullity of T, it is precisely the dimension of V. So here the problem actually gives you a linear operator from V to V, where V is of dimension n, and uh, it gives you another uh, criterion, that rank of T is less than or equals to rank of TQ. Now as you can see, both, so I will write it in another uh, color. So rank of T plus nullity of T, so this is equals to n, and rank of TQ plus nullity of TQ, this is also equals to n, because both are linear transformations or linear operators from V to V. So both TQ and T, they are both linear operators from V to V. Hence the rank nullity theorem will hold like this. So because rank of T is less than or equals to rank of TQ, what you have is that nullity of T is greater than or equals to nullity of TQ. It's pretty simple. Let's say inequality. So both of these things added gives you n, and this is less than or equals to this, then this is greater than or equals to this. But one of the observations that you need to make here as well is this, that the null space of T is always contained in the null space of TQ. So NT is the null space, right? Because if for V, T of V is equals to 0, then T cube of V is of course equals to 0. So this implies that nullity of T is less than equals to nullity of TQ. So if you combine these two things, it implies that you have nullity of T is equals to nullity of TQ. So both of these are, generate a subspace of V, right? And since their dimensions are same, they generate the same vector space, let's say null space of T. So now null space of T is practically equals to null space of TQ. So from here, what you can actually do is this. So let's say that let V belongs to the intersection of null space and range space. So let's say I'm talking about null space of T as this intersection with range space of T. Okay. So, and suppose that V is non-zero. So what happens is that since it is in the null space, you get T of V equals to 0, which also implies that T cube of this V is equals to 0. So now since V is also in the range space of T, it implies that there exists some V prime such that T of V prime is equals to V. Okay. So now just apply T again. So T of V prime is equals to 0 because I have T of V equals to 0. So this is applying both sides. So from here, what you can actually do is this, that V prime belongs to the null space of T cube, because if T square of V prime is 0, then T cube of V prime is also 0. But you know null space of T cube is equals to null space of T. This implies that V prime, this implies that T of V prime is equals to 0, but we started with T of V prime equals to V, hence we have V equals to 0. Thus, in this question, this is the answer, that null space intersection range space is only the 0 vector. Okay, so one thing to understand here in this problem is what have we done? We have just used rank nullity theorem to our advantage. Okay, just go through rank nullity theorem precisely enough and we will be able to solve it explicitly. Thank you for joining. That's all for today. We will meet with another problem in the upcoming TIFR session.